All right, alternating series. So alternating series, honestly, are one of the series that is most likely to converge. Okay? It's sort of the default position. It's like, it's probably going to converge. So here is the idea with an alternating series is just your terms alternate back and forth between positive and negative. And the order is not important. Okay. Here's what you need to have in order to have a series that alternates that converges. So a sub n needs to be positive all the time. And some people are like, wait a minute, I thought it was an alternating series. Okay, hold on. The a sub n is separate from the alternating part. So this part needs to always be positive so that it's just alternating, not like double alternating or something like that. Well, there are series like that where it's negative, negative, positive, positive, negative, negative, positive, positive. This doesn't work for that. Okay? So those alternating series will converge if two things happen. There's only two conditions. The limit as n goes to infinity of a sub n is equal to 0, which is necessary for passing the nth term test for divergence anyway. And the terms are always getting smaller. That is, a sub n plus 1 is less than or equal to, actually, a sub n for all n. So the terms have to be getting smaller to 0. That's it. Why does this work? Well, think about it this way. If this is a sub, this first blue line represents a sub 1. So that would also be s sub 1, the sum of the first term, right? So we're sort of going to do a sequence of partial sum ideas here. Okay, remember the sequence of partial sums, you add up the first 3 terms, then you add up the first 4 terms, and you see what happens. So that's my first term. When I add a sub 2's got to be shorter than a sub 1, right? So now I have s sub 2 is here. I'm going to switch back to blue. So then a sub 3 has got to be shorter than a sub 2. So then our s sub 3 is here. Then my a sub 4 has got to go the other direction because it's an alternating series. So then my s sub 4 for my sequence of it's something's got a loose screw. It's probably because that one's on top of it. So if I keep doing that, go away, Irfan. If I keep doing that, you notice that these are going to continue to bounce back and forth, but they're going to eventually kind of meet in the middle someplace. Now, where exactly they meet, we haven't figured that out. But you can see they're converging on some value. Okay, that's the whole idea. So if you have an alternating series, if the terms continuously get smaller towards 0, then the series is going to converge. Okay? All right. So notice I pointed this out. If an alternating series fails the first part of the test, it fails the nth term test and therefore diverges. All right. So We want to just determine the convergence or divergence of each of these series. This is the alternating harmonic series. So this is an alternating series. We want to look at two things. Is the limit as n goes to infinity of 1 over n equal to 0? Check. Is 1 over n plus 1 less than or equal to 1 over n for all n? Check. This series converges. And it really is kind of that easy. I know you're expecting, like, okay, where's the catch? So here, again, this is an alternating series. The limit as n goes to infinity of n plus 1 over n is equal to 1. Therefore, this series diverges. By the nth term test, so if you ever have to do this in words, this is one where there was a phrase that I heard someone say at something I went to for College Board. I can't remember what it was. But basically the phrase was this: it's an alternating series whose terms decrease in absolute value to 0 converges. It's a nice succinct way of saying that. All right. So what else is there to this? Well, one of the things that we might want to know is how good is our approximation? So like if we've added the first 8 terms together, how close are we at worst from our actual sum? Okay, and this is where the alternating series remainder theorem comes in. If a series converges by the alternating series test, so first it's got to be a convergent series, otherwise this does not work, then the absolute value of the remainder R sub n involved in approximating the sum by S sub n, or that's the sum of the first n terms, is less than or equal to the first unused term. So in other words, after I've added several terms together, the absolute value of the difference between what I have gotten and the actual sum is called the absolute value of the remainder, R sub n, and that will be less than or equal to a sub n plus 1, the next unused term. So if you've added the first 10 terms together, all you have to do is look at the positive part of the 11th term, and that's the maximum error you could have. And the reason that that works, let's go back to this just real quick. You don't need to actually go back. So if I just added the first two terms, right? The next thing I'm going to do is I'm going to add on term 3, right? A sub 3. And I'm going to get this. This is going to be S sub 3. So we know that that's as far off as we could possibly be. Let's say every term after that was 0. Well, this would be how far off we were. Okay, we can't be any further away from the true answer than the next term that we haven't added in yet. Okay, does that make sense? The wording is a little bit awkward on that. So, approximate the sum of the series, which is a summation as n goes from 1 to infinity, of negative 1 to the n plus 1, times 1 over n factorial by its first 6 terms. So, first we need to check, does this thing actually converge? Well, do the terms of this series decrease in absolute value to 0? So this converges. So again, if you want to write it in words, you can do that. If you don't, you have to show both of those tests. So either the terms of the alternating series decrease in absolute value to 0, so the series converges. Or you can do the limit as n goes to infinity of 1 over n factorial is equal to 0. Check. 1 over n plus 1 factorial has to be less than or equal to 1 over n factorial for all n. Also check. It's kind of about the same amount of writing. One way or another, you got to show that the series alternates before you start using the alternating series estimation theorem. So to approximate the sum by the first 6 terms, well, that's just going to be negative 1 to the n plus 1. So that's going to be positive 1. So this is going to be 1 over 1 factorial minus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial minus 1 over 5 factorial plus 1 over 6 factorial. And honestly, that's all you would have to do for this problem. Sorry? Oh, did I do 2 pluses in a row? Thank you. Where's Lynn when I need her? Thank you, Lynn, for a day. So let's see, this would be 1 minus a half plus 1/6 minus 1/24 plus 1 over 120 minus 1 over 720. This is equal to 0.63194 repeating, apparently. A follow-up question to this is, what is the maximum error in this approximation? Well, it'd be 1 over 7 factorial. Which is 1.984 times 10 to the negative fourth. It's a pretty good approximation.
Yeah.
Follow-up question to the follow-up question. Which way is this off? God bless you. Is it too big or is it too small?
Too small because we ended with the minus.
Exactly. It's too small because we ended with a minus. Now, I will say that your book, they sometimes ask, between what two numbers will this approximation lie using the first 6? And they will take this approximation plus or minus the error. To which I say, bull. Think about it a little bit. It's between this and this number plus this number. They give a bigger range than they really need to. Ron, I'm going to send Ron a strongly worded email.
Why the maximum error is 1 to this minus 7?
The maximum error is the next term that you haven't used.
So it's going to be the 8 and the AF and plus 1.
It's going to be what, I'm sorry?
Never mind. So just next term.
It's just the next term. That's going to be your maximum error. And my next term is going to be positive, so that means that this was too small an estimate. It's an underestimate.
I don't remember if I ever talked about it.
Just a minute ago, right here. That's what all that was.
I probably didn't pay attention.
Okay.
It's actually off by 1.76 times 10 to the negative 4.
You did the entire series?
Well, I put the series and I did it to like 26 because after you get to like 20, it doesn't change anything.
It's changing at decimals beyond your calculator's capacity. Yeah.
And it can't do factorials over like 70 or something, I think. The calculator can't do factorials over like 70 factorials.
It's like once you get past, what is it, e to the 10th?
It's e to the 100. It can't do
e to the 100th is where it craps out.
That's where it gets overflowed. Cannot compute.
All right. So here's a different problem. Determine the number of terms required to approximate the sum of the summation as n goes from 0 to infinity of negative 1 to the nth over 2 to the nth times n factorial, which is exactly equal to 1 over the square root of e. And you're like, what the heck, really?
That's fun.
With error less than 0.001. So what we want is we want to find the first term that is less than this. Because the remainder, r sub n, is going to be less than or equal to 1 over 2 to the nth times n factorial, and we want that to be less than 0.001. You could just do this by trial and error. You can also, I didn't want to do that. You can also use your calculator for this. So the easiest way to use your calculator for this is to put this expression into y1. So 1 over 2 to the nth n factorial. And then go to the table. And, oh, and look for, this is 1/1000th, right? So look for the first place where this is less than 1/1000th, and it's right there. So I would have to go to 5 places to get a term less than that. So I only need to add the first 4. Now I'm thinking I wrote something wrong. Hang on just a second. Okay. Yeah, let me rewrite that. That's not the best way to write it. Write it this way instead. R sub n is less than or equal to, it's the n plus first term. So 2n plus 1, n plus 1 factorial is less than 0.01. Sorry. So if I go back to my y equals, there we go. Because the remainder is less than the next term. So if we go to the table now, you'll notice same values. We get n is equal to 4. So it would be the fourth, we need to add the first 4 terms. We got there the same way the other way, but the thinking was a little convoluted.
Yeah.
All right, any questions?